I'm on break. I'm on vacation. Woo! Teaching remotely. That's right. Woo, my glasses are fogging out. Goggles, not glasses. What am I saying? Oh, shot of water. Uh-oh. Gotta get some sunscreen on. Yeah. Gotta get you some beverage and salt water in the mouth. There we go. Oh, man. Product placement. Cascade Ice. Money. Anyway, let's get down to business. Better take those off, we can't see anything. Alright guys, as you see today, we're going to talk about faith and science. Oh no, put those like that and get that thing out of here. Don't need a snorkel on land now, do I? Anyway, unless I'm skiing the powder, but I'm not today. So, anyway, we're going to talk about faith and science, guys. And that's right. That's what we're going to do. And there's a couple reasons I'm doing this lesson as the third and final lesson of our review. Better not have another sip of Cascade Ice. Refreshing, even for the most demanding of sports. I'm joking, by the way, about product replacement. It's silly. But anyway, okay, you guys. So what we're going to do today is we're going to talk about faith and science. And the reason I'm doing this question on faith and science specifically, not only because it's a very good and interesting topic in itself, its own right, but also because the question about trust, that every knowledge claim entails a certain amount of trust. And you can almost synonymously place faith and trust together in that sentence. So think about this as being trust, not necessarily faith, but nevertheless, okay? So this says science is the great antidote to the poison of enthusiasm and superstition. Adam Smith, The Wealth of the Nations, okay? So he's saying science will fix the problems that we have with believing in nonsensical, superstitious stuff. I'm not going to go too into depth to this, but there is a belief in the 1700s that science could answer all the questions that we ever had. That we could completely and absolutely get rid of the concept of God, really. Atheism starts really kind of taking speed, gaining some speed as a philosophical construct during the Industrial Revolution. And anyway, but let's take a look at it. I mean, is science and faith or science and trust two different things altogether? All right, so talk briefly. I'm going to skim through some of these because once again, this is a review. But nevertheless, as the world becomes or the role of science in general, as the world becomes all the more secular, it is increasingly important to role in our society. Science very often replaces other traditions. And, you know, like superstitious traditions such as, I don't know, what's the word I'm looking for? Things like voodoo, things like magic, things like witchcraft, things like, I mean, you could even say like ancestor worship and stuff like that. And to a large extent, even religion itself is displaced by science. And for many that have not displaced, and not had science displace their religious belief completely, very much science has made people kind of reassess the religious claims, like around evolution and so on and so forth. Okay, so it's just kind of interesting here. Okay, generally the idea, like I said, I'm going to do these ones quickly. Generally the idea here is that science has taught us to believe what is observable and reject that which is not observable. If it's observable, it can be true. If it's not, it can't be. So anything to do with like telekinesis or other paranormal activity or you know, belief in ghosts or whatnot. All that stuff, we just say, no, that's nonsense. There's no scientific backing for that. None at all. Anyway, so and we reject claims that cannot be backed up with scientific data. I'm getting good at that. All right, so faith, okay? Many traditional areas are based on faith. How about science? It kind of depends. So this is an excellent definition of faith. I love this definition of faith. It's the favorite one I've ever seen. Faith here is defined, and I'll put it up there, above the palm tree. Hey, palm tree. Okay, wait. Anyway, so it's a particularly unshakable form of belief based on ideas, teachings, and reported historical events, which to the individual seems conclusive. Think about that for a second. All these things you've been taught, all these traditions that have been passed on, and to you that seems conclusive. It's a kind of a faith is kind of very much related to certainty, and obviously there's going to be a little bit less, less confidence in the claim than you were certain, but it's kind of within the realm. So when we say things like in history, I'm sure I've talked about before, when we say things in history like so and such war happened, and in 1066 the Normans invaded England and whatnot, when we make those claims, we have to have a level of faith in it because obviously we weren't there. It seems conclusive, reported historical events, and so on and so forth. Okay, so now there's two different sides to this, and I'm going to argue first one side and then another side. First, I'm going to argue that there is no faith in science and give the reasons for that. And like I said, put the word trust in there. This is directly related to topic 1 this year. Anyway, it's summer for me. But anyway, and then I'm going to argue that there is faith in science, okay? And so here's the ideas. I don't think my PowerPoint has that much on it. I made it that way particularly. Okay, so I'm just going to talk a bit. And so if you're going to make the claim that there's no faith in science, what you're saying basically is that it is completely based upon empirical data, that we can't go around having faith in science because we have to have proof. You cannot make scientific claims. You cannot go into the lab and say, it feels good. Well, let me see your data. Well, I didn't really do any data because, you know what? I figured out the cure for cancer, and the cure for cancer is that you take a bunch of blueberries, you mash them together in a bucket, you put some bleach in it. Bleach is good for pretty much killing everything. And then you put a little turpentine in there, you mix it around, you put some cornstarch, some baking powder, put it in the oven, and put a mask on because it's going to steam. Put it in the oven for 2 hours at 250, and you've got a cure for cancer. And people would be like, okay, yeah, right, so maybe, but let's see the evidence, let's see the trials, let's see the sort of control group and experimental group. Let's see the science. Science is about controlling things and getting data to back up your claims. And so, obviously, this guy making his weird experiment and probably poisoning himself in the kitchen, he wouldn't have anything. I mean, you can't go to your doctor and the doctor says to you, yeah, well, I've never done one of these heart surgeries before, but I'm feeling good about it, feeling good right here. I'm feeling good. I got trust in myself. I know I can do it. I've seen it. So watch the YouTubes a bunch of times. And so anyway, so obviously you can't say that these these sorts of things are based on faith. You can't have faith that your calculations are going to work when you're building an airplane or sending somebody into space or building a bridge. You have to have the actual science. It has to be observable. It has to be objective. It has to be based on something we know. And the only way that you can know something in science, to know it in science, is to observe it. Once again, I'm getting away from the debate, the Descartesian debate about, we can't believe anything that we see because we might just be brains in a bucket. We just have to remove that from a philosophical possibility for this conversation. I mean, we can talk about it interestingly, in another time, but I mean, that doesn't really, anyway, it doesn't help. And so that's why I'm not really bringing it up. Or I did, but. Nevertheless, so you get the idea. And I don't really need to get into that one so much because We understand that already. We understand that science is based on rigorous proof, on experiments. It's on, trying to falsify, on all these things that I've already been talking about. It's based on the scientific method. It's based on watching your hypothesis correspond with expected reality. It's all these things, and science works, and it does all these sorts of things. Okay, now, all right? So let's take a look at the other argument, though, that there is an element of faith in science, or that there is an element of trust in science. And so let me go into, I put a picture up here of the telescope there. It's just observing what is really there. I mean, us observing things is not creating it, anything like that. We're observing an outward reality that exists. And that's the thing. I mean, whether we know they exist or not, and whether we ever see them or not, they still exist. And so the science is the observer of the existing reality, and we're making sense of a reality that exists outside of us. It comes to the question of subjective and objective truths. My subjective reality does not correspond at all with the objective reality. I'm a subject, that's an object. I can't necessarily do anything but comprehend it through my own subjective understanding of things. And that's the idea, and that's where we start confusing ourselves with thinking that our subjective reality is the objective reality. But science doesn't work that way, and as a matter of fact, science has really nothing but disdain for the subjective interpretations of things, because it gets away from scientific objectivity. And in the end, it means if we let subjectivity into science, that it becomes less effective and less pragmatic. If people are going around basing their bridge design on faith and their feelings and all that kind of stuff, well, they're going to crash down. So that's the idea with that. And so let's talk about this argument instead. That there is very often, maybe not always, but very, very often, an element of faith in science. And you have to think of, and I've mentioned this several times, there's two types of people, there are probably more, but there's two types of people dealing with science. Just to simplify it and say there's two. There's the producers of science and there's the consumers of science. All right. Now, you guys have all heard about the atom, the development of the atom, the different models, the Bohr's model and Rutherford model, and the different models of the atom that they developed over time. I mean, even in what was his name? Atomos is the first guy in Greece who came up with the idea of an atom, and when he walked up the steps to not the Colosseum, but anyway, whatever, that thing, Acropolis. So he walked up the steps to there, up to the market somewhere. I'm not sure where he was walking, but the steps are wearing off, and he says, well, those steps must be made of small little particles, and smaller, and then he said the smallest thing in the world was an atom. People tried to prove that, and they kind of did, but then we know later that it's not. But anyway, I mean, there's quarks and there's electrons, and there's the whole. And you guys know the story. You've been in science, and so. But here's the question: who's ever seen an atom? Nobody's actually ever seen an atom. Doesn't mean I'm not saying they don't exist. That would be absolutely silly. But nobody's ever seen one. As a matter of fact, as far as I understand, even with the best microscopes in the world, you can't see an atom. You deal with atoms that are there. And they know they're there, I guess, because of indirect proof. But at the same time, nobody's ever seen one. Now, this doesn't mean that I think that the scientists who believe in atoms or know that atoms exist are somehow fooling themselves. That's not at all what I'm talking about. But how about you and me? I wouldn't even know about how to go about proving the existence of an atom. Doesn't mean I couldn't learn it. But I don't know. I'm taking the word for it. I'm completely and utterly taking the word for the existence of an atom. I don't know. I've never seen one. I don't know how I'd go about seeing one. People tell me they're the smallest particle, and then they said what used to be thought the smallest particle. And so this is the idea. I mean, there's lots of different examples on this. I mean, how about vaccine? You're putting your trust in the efficiency of the vaccine. How about, you name it. There's so many things like that which are involved. And, the atom's kind of an interesting example for this. And I'm going to give you another example, a real life example. And this was one of the most fascinating historical examples of science. and you guys should look up this example. I can put a link there for it. But you guys should look up the example, and it's an example of luminiferous ether. And not only one of the reasons I like it the most is you get a decent story. Okay, I need another sip of my Cascade Ice.
Money, money, money.
Refreshing. Yeah, I'm getting a quarter every time I say that, so I'm going to say it a whole bunch of times. But anyway, okay? So luminiferous ether. What was what was it proposed to be? What I can't even say it, jeez. Luminiferous ether. Okay? Here's the idea. This is also a good example of how induction can steer us wrong. Okay, you've all seen the thing, the movie Alien. Maybe you haven't seen it, but maybe you've heard of the sort of like whatever you want to call it, the catch line or the whatever. In space, no one can hear you scream. All right? No one can hear you scream in space. I'm screaming in space. Maybe because no one's there. Anyway, so no one can hear you scream, and why can't anybody hear you scream in space? Well, because there's no air. And why is there no, well, not why is there no air, there just isn't. But why can't anybody hear you if there's no air? Well, because air carries sound waves. So my little voice is coming over there and hitting that speaker, and something's happening there, some digital thing's happening there, but anyway, it's carried on the airwaves, and it can pick it up. And so there's other things that carry sound waves. Water carries it better. We can't hear as good underwater because we don't have water ears, but apparently it's like way better. I think it's 10 times or something better carrying sound waves underwater. And so anyway, but we have, like I said, it doesn't really sound like that for us because we get water in our ears. We don't have water ears. But like dolphins and other fish and stuff like that. Whales. But anyway, so nevertheless. So now, and this is where it got really, really interesting, is how about light? How does light get from point A to point B? How does it get there? How does light get from the sun here, or from that spotlight to me? Where does light go when you turn it off, by the way? You ever thought about that? Just, what is it in the first place? What is light? Okay, it's photons, but I mean, why are they light? There's a million mysteries around light that people still don't really understand. And nobody really quite understands, I think it's fairly theoretical, nobody really quite understands how light actually gets from point A to point B. And so this is, it's really kind of fascinating story. But anyway, so using induction as a way of knowing, scientists believe that if light traveled from point A to point B, like sound, it needed a medium on which to travel. Okay, there we go. A medium on which to travel. And what did they call this medium? They called this medium luminiferous ether. They believed that space was filled with luminiferous ether. All over. Light couldn't travel from one place. I don't know what would happen to it if it would just like sit there and not go anywhere. But light could not travel without luminiferous ether. And so the existence of luminiferous ether was taught in physics for generations. For generations. There were even some studies that confirmed it, which were later falsified, but there were even some studies in which, so people believed it totally, and so physicians and professors, they taught it to their students. The students grew up and became physicians and professors and taught it to their students who grew up and became physicians and so on and so forth. And it was like early in the 1900s when they disproved the existence of it. But so it's fascinating because this shows you the level of belief and authority in science. It shows you the level of faith and trust in the scientific narrative that's being taught. Because how would I, as a student at that time, have the ability to even test if what they're saying is incorrect? How could I do it? Now, by nature of science, you see, people are saying, well, we can't really say this. This is still a theory unless we have proof, and they failed to prove it, failed to prove it, failed to prove it, failed to prove it, and eventually, they pretty much disproved it, and so on and so forth. So, I mean, that's the scientific process working like it does, but you see at the same time, for generations, a perpetuation of incorrect knowledge was spread to people down the chain of human knowledge. So it's an excellent example to talk about to talk about what kind of trust that we need in the areas of knowledge of science. And it's for that reason that I'm redoing this lesson a little bit more in depth. But anyway, like I said, it's fascinating. And so that's pretty much it as far as this lesson is concerned. And so now I'm going to go do some more diving. That's right. I'm going to go do some more diving. I'm tired of teaching. I want to do some diving. Better get my snorkel. Anyway, guys, so enjoy the sun. And, well, I'll figure out my snorkel when I get to the water. And I'm just going to play some outro music. Some more cool outro music. Some beach music.
You guys should try diving sometime. You should try diving sometime. Dive fun.